everyone, and welcome back to another professional prep video. In this video, I am going to be talking about some other forms of derivatives, which are natural logs and derivatives of base e. So I'm actually going to start out with natural logs. I personally sometimes like doing the harder one first, and you'll see why natural logs are harder than e to the x. But natural logs are not hard at all. So the derivative of, once you get some practice, it's not that hard, I should say. But the derivative of natural log of x is actually just 1 over x. So that's pretty simple, but wait till you see the derivative of a base e function. That's going to be even better. So natural log. So last time you had to memorize 6 trig derivatives, or maybe you're still memorizing them, which is great, but this time I'm only going to show you 2 new ones. And natural log is not that hard to remember, but e to the x is going to be very simple. The derivative of e to the x, well, it's just e to the x. And that's actually true. So those are the only 2 functions we're going to play with today. So now that you have those 2 derivatives down, let's just do a couple of examples. Let's just do one example for each. And I'm going to involve some chain rule. Chain rule is a huge rule that you cannot forget. So let's say that we want to find the derivative of, let's do the natural log of 3x squared. Alright, so first what I'm going to do is I'm just going to apply the formula that we have. Derivative of ln x is 1 over x. So the derivative of ln 3x squared, 1 over 3x squared. Simple enough there, but there is chain rule here. It's a composition. So we need to multiply by what's inside of that ln, or the derivative of what's inside of that ln, I should say. The derivative of 3x squared is just 6x. And so very simple. That's what we get. So we can just bring that 6x up to the numerator and call it 6x over 3x squared. And we can go to simplify this a little bit, actually. I think I will. You can cross out an x. The 6 over 3 just becomes a 2. So I believe what we're going to see here is 2 over x. Yes. And there's the simplification. And there you go. So there you have it. That's a derivative of a natural log using chain rule. And now let's do a derivative of a base e function using chain rule. This one is probably going to be very easy if you understood that natural log one, given that we have that simple form that maintains itself. So, derivative of, let's do e to the 5x. So, first step, the e to the 5x, derivative of e to the x is just e to the x, which means that the e to the 5x stays itself, times, this is obviously a composition, so chain rule is involved, so times the derivative of what's inside. Here the 5x is inside, so you multiply by the derivative of 5x, which is just 5, and that's a perfectly fine answer, or you can just combine it into one term by simply bringing that constant of 5 out in front, and you get 5e to the 5x. And that is your answer. So there's a couple of worked out examples using some chain rule, so there's some chain rule practice, and our 2 new derivatives here. So that's all I have for you for this video. If you have any questions, please email or leave a comment. And please make sure to subscribe to our channel. Have a great day, everyone. I'll see you for our next video.